Welcome to The Explainer. Today, we're going to break down a topic that is, no joke, the bedrock of all calculus: limits.
This is it. According to our source material, this is the single most important lesson in your first year of baccalaureate math. Heck, maybe your entire high school career. We're talking about limits, or as they're known in Arabic, an-nihayats.
So, why all the hype? What makes this so crucial? And more importantly, how can you absolutely master it? Well, the source material gives us a complete roadmap, a master plan for success. So let's jump right in and walk through it together.
All right, so first things first. Let's get into why this is so important. The source makes it crystal clear. This is not just another chapter you can cram for and forget. No way.
I mean, look at this. It's the main event for your first big exam in the second semester. But even bigger than that, your entire second year of baccalaureate math is built on this one single idea. So if you master it now, you're basically setting yourself up for success later on. It's a total game changer.
Okay, so with all that build-up, what is a limit, really? When you strip it all down, the source explains it in a way that's actually surprisingly simple.
Think about it like this. Calculating a limit is pretty much just finding the value of a function at a certain point. You literally just substitute the number in for x. So, for example, if you've got the limit of x squared plus 2 as x gets closer and closer to 3, what do? You just plug in 3. So 3 squared is 9 plus 2, that's 11. That's it. Easy, right?
So if it's that easy, why on earth is there a whole lesson on it? I mean, that's just basic algebra, isn't it? But this is where it gets interesting. Because sometimes when you try that simple substitution, you run into a huge problem.
And that problem brings us face to face with the main villain of this story, something called indeterminate forms. These are the tricky situations that the entire study of limits was invented to solve.
Okay, check this out. This slide shows it perfectly. On the left, a nice, simple limit. We plug in 0 for x, and we get a clear answer, 2. No problem. But look at the right side. We try to do the same thing. We substitute 1 for x, and we get 0 divided by 0. What does that even mean? Your calculator will just throw an error. And in the world of math, that's what we call an indeterminate form.
And it turns out, there are 4 of these bad boys you need to look out for. These are the 4 villains we've got to learn how to beat. Anytime you do that first substitution and you end up with one of these, you know you've got more work to do. You can't just stop there.
All right, so we've identified the problem. We know the enemy. Now how do we fight back? This is where the source gives us an absolutely brilliant master plan, or khutata, as it's called. This is your comprehensive guide to tackling pretty much any limit problem that comes your way.
Let's start with the basics, polynomial functions. You know, the ones without any messy fractions or roots. The plan here is super straightforward. If you're finding the limit at a specific number, you just do what we did before, direct substitution. But if you're finding the limit at infinity, you do something kind of cool. You only pay attention to the term at the biggest exponent.
But wait a second, why can we just do that? It feels a little like cheating, right? Like we're just ignoring parts of the equation? This is a great question, and it's definitely something your teacher might ask. Is this just a lazy shortcut, or is there some real math behind it?
And the answer is, it's all about factorization. The secret isn't a shortcut at all. We're not just ignoring the other terms, we are mathematically proving that they become totally insignificant.
Here's how it works, step by step. You take that term with the highest power, let's say it's x squared, and you pull it out of the entire expression. You factor it out. Now inside the parentheses, all the other terms have turned into fractions, right? Something like 5 over x, or 2 over x squared. So what happens when x becomes mind-bogglingly huge, like on its way to infinity? All those little fractions, they shrink down to basically nothing. They all approach 0.
And that brings us to a fundamental rule of limits. Any number divided by infinity is 0. The source gives this amazing analogy. Imagine you have 1 apple, and you have to share it with 1 billion people. How much apple does each person get? Pretty much nothing, right? It's a crumb. It's effectively 0. And it's the exact same idea in math.
Okay, what about rational functions? You know, the ones with fractions. Well, for limits at infinity, the rule is pretty similar. You take the highest degree term from the top, the numerator, and you divide it by the highest degree term from the bottom, the denominator. But when you're looking at a limit at a specific number and you hit that classic 0 over 0 problem, you need to pull out a special tool from your toolkit.
And that special tool is called polynomial division.
What this awesome technique lets you do is factor the top and the bottom parts of the fraction. And when you do that, you'll be able to find and cancel out the one little piece that's causing that zero in the denominator. Once you cancel it out, boom, the problem is solved and you can get a real final answer.
Okay, that was a lot, so let's boil it all down. What are the absolute must-know, key takeaways that you need to have locked in for your exam?
This is it. Your 3 keys to success. Number 1, always try direct substitution first. Don't overthink it. Just plug in the number. If that gives you one of those 4 indeterminate forms, then it's time to bring out the master plan. For polynomials at infinity, just use the highest degree. For rational functions at infinity, it's the highest on top over the highest on the bottom. And for that really common 0 over 0 problem at a number, your go-to weapon is polynomial division. That's your whole game plan, right there.
And the source wraps it all up with this really powerful thought. You've got the plan now. You have the complete roadmap. And when you combine that plan with your own practice, with your own hard work, success isn't something you just hope for, it's pretty much inevitable.